In this video, I will show how to find the volume of a pyramid with a given height and rectangular base that has certain dimensions. The idea is we can find the volume as long as we can find the area of the cross section. And let's set up the coordinate plane. So let the x-axis coincide with the altitude and pass right through the center of the base and starting at the tip of the pyramid. Then we can label this point as it has coordinate h. Then we can assume that this length is b and this length is 3b. So this pyramid satisfies the given conditions. Now we're going to consider the cross sections perpendicular to the x-axis. And the idea again is the volume of this pyramid is equal to the integral from 0 to h. We're going to integrate the function with respect to x. And what function are we going to integrate? The function that is the area of the cross section. So now we need to find the area of this cross section as a function of this x. The cross section is a rectangle, and this rectangle is similar to the larger rectangular base, so we can assume that its dimensions are a by 3a, and then the area of this rectangle is simply 3a squared, where a is this length and 3a is this length. So now we just have to figure out the relation between a and x. And for that, let's consider the following figure. And we can assume that this is 3a, this is 3b. The altitude of a smaller triangle is just x, and the altitude over a bigger triangle is h. Due to similarity, x over 3a is the same as h over 3b. Therefore, a is equal to xb over h. And now we can finish writing the formula for the area of that cross section. It's going to be 3 is xb over h squared, which is 3b squared over h squared x squared. And this is the formula that we will be putting inside of this integral to find the volume. So 3b squared over h squared times x squared. And this is the integral that we have to evaluate. So it's a relatively simple integral. We can take the constant out and integrate x squared, and the derivative of x squared is x cubed over 3, and we evaluate this integral from 0 to h. We can cancel 3's, so I have b squared over h squared times h cubed minus 0. So the final answer is b squared h. So this formula confirms the formula from geometry that suggests that the volume of a pyramid is 1/3 the area of the base times the height, which is also b squared h. So this is how we know that we found the volume correctly.